Hey guys, thanks for checking into BrainWaves this week. Before the show gets started, please do us a solid and rate the podcast on iTunes. It kills me to see that when I search BrainWaves on iTunes, I see shows about comic book reviews and outdated mental health podcasts come up before our show. So, take a minute, rate our show, let us know how we're doing. Now, on to the episode. This episode is called Neurostimulants, but we're really talking about caffeine today, and I can't tell you how excited I was to do this episode. And it wasn't just caffeine I was using that made me excited, it really was the topic of caffeine. There are so many crazy things to know about it. Did you know it can be absorbed through the skin? Seriously, the skin. Or that it actually makes people smile more? Like, it can make you a happy camper. And caffeine is something that's just so common, why wouldn't anyone want to know more about it? I'm going to introduce this topic with a story. My story. My first real exposure to caffeine came in college. I was a junior, studying at Johns Hopkins, working part-time at a local pub to pay my way through school. And I took on a job at the National Institutes of Health. My boss, Richard Allen, who specializes in sleep disorders, ironically, would have me come into work during the summer every morning at 6 a.m. This was about 2 hours after he'd already been in the office. In full disclosure, he never pressured me to come into work at 6, but I felt like a bum showing up at 8, which would have been 4 hours later than he did. 6 was a compromise. So I would make my way into his office at 6 via a pretty slow commute, requiring a 10-minute walk to the bus stop, one bus to the main Hopkins Hospital, then walk to the second bus to take me to the satellite campus, the Johns Hopkins Bayview Medical Center, and the National Institute on Aging NIH branch. In total, the trip would take a bit longer than an hour. The buses were pretty frequent, so waiting was never much of an issue. Worst case scenario, I would spend 3 hours of my summer days commuting. No problem. I could read papers, make notes for the day's experiments, work on my laptop. But after a while, the 2 or 3 nights a week I worked for the bar caught up to me. I'd get off work between 2 and 3 a.m., go to sleep, and wake up at 4:30 a.m. for the morning shuttle. I've had a better night's rest on call in the ICU than that. So I had to figure something out. Quitting my job wasn't an option. Had to pay the rent. Giving up my lab position was also out of question. I had been convinced by my graduate program guidance counselor, who, by the way, was kind of a jerk and told me I would never get into medical school. He told me I had to work in a lab during these years. It was one of those things any Hopkins pre-med had to do. So how was I going to go about doing this? Hello, coffee. I didn't make enough money bartending to afford a Red Bull every morning, and even at Hopkins, I didn't know the right people to hook me up with Adderall or any other psychostimulants. Not that I would have taken them, I guess. So I resorted to coffee. And not the Starbucks kind, the Costco kind. And boy was I amped. I became so productive and energetic that I convinced my mentor to pay me for the work I was doing. And this was kind of unprecedented for Hopkins, by the way. It's usually such a privilege to work there that paying an undergraduate to be a lab assistant simply wasn't done. Caffeine got me out of bed, it lifted my spirits, kept me awake on the hour-long commute to Bayview. It helped me to run a 24-hour time course experiment at the NIH, where I was fiddling with cells and petri dishes by myself throughout the night. I still credit the success of that experiment to my friend Danny Brussel, and the entire sleeve of Oreos we ate that night, but also to caffeine. And caffeine allowed me to continue to work at the NIH after summer had ended and classes resumed. Somehow I was able to work 25 hours a week, take a full course load, work the bar a couple nights, and graduate with 2 degrees. Caffeine literally was the miracle drug I'd been dreaming of. But then I noticed it had become a problem. In the mornings after working at the pub, I would be drinking a Nalgene full of iced coffee through my 8 a.m. class. Wawa doesn't even serve coffee in that size. Even more, I would help myself to a sizable serving of soda at lunch, tackle another cup of coffee by the early afternoon, and then grab at least another cup or 2 in the evening to study and write papers. In all, about 7 or 8 cups of coffee per day. In milligrams of caffeine, that's about 600 or 700. I couldn't stay awake without it. I wouldn't say I was addicted to it. Well, maybe not addicted. I never really craved it per se, but I definitely depended on it. I depended on it to the point that either it or my sleep deprivation would make my hand tremor, or give me palpitations. I needed it so much that I ignored the fact that I was taking an anti-anxiety pill every day just to keep an even temper and stave off panic attacks. I guess I've seen worse in friends of mine from college and medical school. They would pop a no-dose, or basically an over-the-counter caffeine pill, a few times a day. Each pill contains about 200 milligrams of caffeine, so maybe a little less than what I was injecting into my own body. Plenty of students were taking Adderall, or the equivalent type of amphetamine, and you can see how this habit could become unhealthy. But where do you draw the line between caffeine as a mediator of productivity and an agent for toxicity? Well, let's talk about it. To understand how caffeine works to your benefit, and how it kept me functioning as a nearly normal college student on 1 to 2 hours of sleep every couple of nights, you should know what it does. Caffeine acts in several different ways in the body. It's a mild diuretic, inhibiting the action of antidiuretic hormone in the kidney. It can burn fat by increasing the basal metabolic rate, causing weight loss, and that's why historically it was used in some weight loss supplements. Caffeine also modulates the activity of multiple centrally acting stimulatory neurotransmitters, notably dopamine, but also acetylcholine, serotonin, and glutamate. It can diffuse across the cell membrane to activate the cyclic AMP protein kinase A pathway as a phosphodiesterase inhibitor, permitting cyclic AMP to build up inside cells and do all the weird things that cyclic AMP does, which I don't really remember. Except to say you probably remember from biology that these intracellular proteins also mediate the signaling of extracellular norepinephrine. So you're basically simulating the effect of more norepinephrine in your system. You'll also remember that norepinephrine acts as the primary neurotransmitter in the postganglionic sympathetic nerve, which mediates your fight or flight response. Perhaps most importantly, as a psychostimulant, caffeine acts by antagonizing adenosine receptors in many tissues. Adenosine, as you remember, is a structural homologue to caffeine and to adenine, one of the 4 nucleotide bases in our DNA. With continued wakefulness as the day goes on, adenosine levels accumulate in many areas of the nervous system, particularly the ventrolateral preoptic area, or VLPO. Without trying to put you to sleep here, the VLPO is one of the major sites of sleep regulation, which utilizes GABA to inhibit the tuberomammillary nucleus, a histaminergic complex that mediates arousal. Ultimately, as adenosine builds up in the body throughout the day, it will inhibit histamine release from the tuberomammillary nucleus, whereas caffeine increases histamine production and increases wakefulness. For athletes, caffeine can improve physical functioning. Using cyclists as an example, it's been shown to increase the duration of maximum performance, increase cycling speed, and improve cycling power, as well as reduce the cyclist's perception of fatigue. A caffeinated athlete is more powerful overall, more powerful for longer periods of time, and the athlete will feel less fatigued than the uncaffeinated athlete. Basically, the caffeinated athlete is the one getting picked first for dodgeball. In fact, until 2004, the International Olympic Committee restricted caffeine intake during competitions to 12 micrograms of caffeine per liter of urine. That's about the equivalent of a whiff of hot cocoa. Basically, no caffeine during Olympics. After 2004, any dose of caffeine as a performance enhancer was permitted. In addition, as any strung-out college student can attest, caffeine improves attention. According to functional MRI data, caffeine has been associated with greater glucose metabolism in areas responsible for mediating attention, areas like the putamen, among other places. It has also been shown to increase synapse formation between hippocampal neurons and improve the long-term potentiation between these cells, meaning the cell-to-cell signaling becomes more permanent. This alteration of cytoarchitecture, or synaptic plasticity, improves learning and cognitive performance, and long-term coffee drinkers have been shown to have a lower risk of cognitive impairment and even Alzheimer's disease. Interestingly, the cognitive effects of caffeine are not dose-dependent, so more doesn't necessarily make you smarter. Just a little bit can. You won't become an Eric Kandel by popping no-dose all day. But maybe that B on your physiology test could become an A. Now, those are all the good things caffeine can do. So what would cause anyone to worry about it? Well, practically anything can be toxic, and caffeine's no exception. To bring you back to the fact that caffeine basically simulates the endogenous norepinephrine your own body produces by acting on beta-adrenergic receptors, let's relate caffeine use to a disorder of excess norepinephrine. Take, for instance, a pheochromocytoma. If you've ever met someone with this type of adrenal tumor, you'll know these patients experience palpitations, anxiety, headaches, tremulousness, muscle twitching, and an odd combination of insomnia and lethargy. Clinically, they may appear hypertensive, tachycardic, or even have atrial fibrillation. It's likely that through these cardiac mechanisms, caffeine overdose has been linked to death. But I've got to say, it's pretty hard to OD on caffeine. Don't try this at home, kids. An adult would have to ingest about 10 grams of pure white, chalky caffeine to die. That's the equivalent of 333 bars of dark chocolate, 200 cans of Coke, or 130 cups of coffee in an hour. It's probably easier to ingest 50 tablets of no-dose to do the job, but this would have to be intentional. That being said, I have heard stories about recreational intravenous caffeine use, and I can't say I'm surprised. Just wish I had heard about it earlier. In excess of its rarely lethal cardiotoxic effects, caffeine can also induce vomiting and increase the production of gastric acid, leading to peptic ulcers and esophagitis. In larger doses, it can lead to dehydration through its diuretic mechanism, and to constipation by increasing water reabsorption within the large intestine. It's been associated with elevations in LDL, or the bad cholesterol, and it has been associated with low calcium balance and osteoporosis. And the withdrawal from caffeine is not pleasant either.
Let it go.
The caffeine withdrawal syndrome can occur almost as rapidly as alcohol withdrawal, over about 12 to 24 hours since the last exposure. Symptoms other than the obvious drowsiness, impaired concentration, apathy, weakness, and reduced energy also include stomachache, joint pains, headache, and irritability. Because of these unpleasant side effects, and the pretty bothersome withdrawal syndrome, what you should take away from this episode is all things in moderation. This includes caffeine, and the BrainWaves podcast. Just kidding. But seriously, remember, this is purely an educational podcast. I'm just telling you what I know. I'm not lending out medical advice about caffeine. And you can do whatever you want with it, but I would be cautious in letting caffeine do whatever it wants to you. These days, I drink mostly decaf. A soda every now and then, and maybe something stronger when I'm post-call. Gives me an edge. Moderate use of caffeine, less than 400 milligrams a day for an average adult, about 4 or 5 cups of coffee, is more than enough to improve attention, memory, and physical performance without causing significant cardiovascular side effects. Despite the rumors you may have heard, caffeine has not been proven to increase your likelihood of cancer, or of male infertility or congenital malformations among infants born to mothers who used caffeine in moderation. Other than that, we really didn't talk much about the use of caffeine among pregnant women and in children, but that's also a hot topic you should look into if you're interested. Unfortunately, we couldn't get into this during the episode today because we're running out of time, but stay tuned next week when we talk more about psychostimulants and their impact in the US military. Thanks for listening to this installment of BrainWaves this week. Of course, I was only kidding about listening to the show in moderation. Please play every episode all the time, just like Ali Hamidani does. Just let us know what you think about it by rating us on iTunes. You can also follow us on Twitter at BrainWaves Audio or Facebook at facebook.com/BrainWavesPodcast. And you can check us out on Instagram at BrainWaves Podcast, where we show imaging and other cool photos. I'd like to thank Caffeine for being on the show with me today. Couldn't have done it without you. The music this week was courtesy of Andy Cohen and Little Glass Men. I'm Jim Siegler for BrainWaves. Talk to you next time.